test the convergence and absolute convergence of the series summation minus 1 whole to the power of n minus 1 into n by 5 to the power of n. Friends, here you observe the given series is containing minus 1 whole to the power of n minus 1, which means if you split this, then the terms will be first one positive. If n is 1, n is equal to 2, we will have minus 1. N is equal to 3, it is a plus 1. So what we can say here, the terms will be repeatedly positive and negative terms. Simultaneously, we will get a positive and negative terms. So we can say this series is an alternating series. Now we have to test the convergence of this alternating series. How many methods we have to test the convergence of an alternating series? Means only one method, named as Leibniz test. Okay, I will repeat again. To test the alternating series, we have only one method. That method is Leibniz test. Okay, now to test this convergence, we have to verify two conditions. The first condition is un is a decreasing series, means un is greater than un plus 1. Next, second one is limit n tends to infinity, un should be goes to 0. Suppose the alternating series is satisfying these two conditions, then we can say the alternating series is convergence by Leibniz test. Alternating series convergence by Leibniz test. Okay, first one is clear. Next one, what? Absolute convergent. What is meant by absolute convergent? If the alternating series is convergent, after that we have to apply mod less on the both sides. Then if you are applied mod for this entire series, then what will happen? You see, suppose the given series is summation minus 1 whole power n minus 1 into un. If you are taking a mod, then this will become a mod un, which is a series of positive terms. Previously, alternating series we have. For that, if you are applying mod less on both sides, means mod less for the given series, then we will get a positive term of the series. We know the methods. How many methods we have? Different methods we have to test the series of positive terms. We can say necessary condition, P series test, geometric series test, limit comparison test, ratio test, D'Alembert's. Okay, like that we have different methods. Okay, if any one of the method the series is convergent, then you say the alternating series is absolutely convergent. Alternating series is absolutely convergent. Okay, if mod un is divergent, then we can say alternating series is conditionally convergent, semi convergent, or non absolutely convergent. Okay, these three are same. Now coming to the solution, friends, here you observe given series I am considering as a mod un, which is summation minus 1 whole power n minus 1 into n by 5 to the power of n, which is equal to summation minus 1 whole power n into vn. So I am considering minus 1 whole power n minus 1 coefficient as a vn. So what is the vn from these two? We can say vn is n by 5 to the power of n. So we have an alternating series. To test the convergence, what we have to do? We have to check these two conditions. First condition is what we have? Un is greater than un plus 1. So take vn. Here vn we consider. So vn is n by 5 to the power of n. Now you take vn plus 1. Now we have to prove vn is greater than vn plus 1, or simply we can prove vn minus vn plus 1 is greater than 0, or vn plus 1 minus vn is less than 0. Both will be same. If you prove this, then first condition is satisfied. Now vn plus 1 minus vn I am taking. Vn plus 1, what I have? N plus 1 by 5 to the power of n plus 1. What is the vn we have? N by 5 to the power of n. So what is the LCM? 5 to the power of n plus 1 is the LCM. Now the first term is n plus 1 as it is. 1 into n plus 1 is n plus 1, minus n is there. But here you have denominator 5n, but here you have 5n plus 1. So 5 will be extra. 5 into n is 5n. If we simplify this, then we will have n minus 5n means minus 4n plus 1 divided by 5 to the power of n plus 1. Numerator, observe friends, 4n minus 4n is there. Minus 4n plus 1 is a negative. Denominator is always positive for any natural number set. So what we can say? Negative by positive will become what? Negative by positive will become negative. So un plus 1 minus un is less than 0, or vn plus 1 minus vn is less than 0, which is proved. Vn is greater than vn plus 1, means vn is a decreasing series. First condition is over. Now second condition. What is the second condition? We have limit n tends to infinity un is equal to 0. We have to prove. Okay. Now taking limit for the vn, limit n tends to infinity vn is equal to limit n tends to infinity n by 5 to the power of n. We know that as n tends to infinity, as n tends to infinity, 5 to the power of n goes to 5 to the power of infinite, which is goes to again infinite. So infinite by infinite only we will have, infinite by infinite. Friends, in this case we can do one thing. Numerator is big or denominator is big? Denominator is big than the numerator, so obviously denominator goes to infinite as based on as early as possible. Okay, now you observe, whenever you have infinite by infinite form, what we will do, we will apply the L'Hopital rule. If you differentiated n with respect to n, then you will have 1 denominator 5 power n derivative 5 to the power of n into log 5. Now you apply as n tends to infinite, it will goes to 1 by 5 power infinite log 5. 5 power infinite means what? Infinite. 1 by infinite means 1 by infinite into log 5 is again infinite. 1 by infinite means 0. Okay, friend. So the second condition of a Leibniz test also satisfies. From this, what we can say, alternating series is convergent by Leibniz test. Alternating series is convergent by Leibniz test. Now what we have to verify, the given series is absolutely convergent or conditionally convergent. Absolutely convergent or conditionally convergent. For that, what we have to do, we have to apply mod for the given series. We have summation un is equal to summation minus 1 whole power n minus 1 n by 5 to the power of n. Okay, now if I are taking a mod for this, then mod un is equal to modulus of minus 1 whole power n minus 1 into n. What is the minus 1 whole power n into n minus 1 will become? Mod of minus 1 whole power n minus 1 will become 1 only. So 1 into n is n by 5 to the power of n. Now you observe, friends, this series is means mod un is containing both the numerator and denominator. Numerator is the nth term, denominator is the 5 power n, nth term only. This is also nth term only. So series of positive terms, we can apply different methods. First, you observe, necessary condition is possible. Limit n tends to infinity, it is goes to 0. So limit may be, means series may be convergence or divergence. We cannot justify by using the necessary condition. P series test we cannot apply. Geometric series test also we cannot apply. Now you can go for limit comparison test. Comparison test is also not applicable. So you can go for the ratio test. And moreover, you can go for a limit nth root test also we can go for. Now I am using a ratio test here. Now ratio test, what we required to find limit n tends to infinity un by un plus 1. So mod un plus 1 I am considering. In place of n I am substituting n plus 1. So n plus 1 by 5 to the power of n plus 1. Now mod un by un plus 1 is, what is the un you have? Mod un n by 5 to the power of n. Mod of un plus 1 is reciprocal, we have to write. So n plus 1 will become a denominator, 5 to the power of n plus 1 will be in the numerator. So 5 power n plus 1 by n plus 1. Now I can split this as 5 power n into 5. This is from the denominator I can take n is a common. So observe, friends, this n and getting cancelled, 5 power n, 5 power n getting cancelled, remaining 5 by 1 plus 1 by n. As n tends to infinite, 1 by n goes to 0. So 1 plus 1 by n goes to 1. So if we are applied the limit n tends to infinite for mod un by un plus 1, we will get 5 only. What is this actually? In the ratio test, this is a limit. Limit is equal to 5, which is greater than 1. So in the ratio test, L greater than 1, therefore the series is summation mod un is converges. What we can say? By ratio test. Okay, from this what we can say? Alternating series is converges first, plus with how it is convergence? By Leibniz test. By Leibniz test. Second one, the alternating series means mod un is also converges. Therefore we can say alternating series is absolutely convergent. Alternating series is absolutely convergent. Friends, here I given a one method, ratio test. Same problem we can do in a nth root test. Now I am going to explain by using nth root test how we can do. Okay, you see, friends, here you have a mod un. What is the mod un? N by 5 to the power of n. Now apply whole to the power of 1 by n for this, and limit also mod un whole to the power of 1 by n. If I applied, limit n tends to infinite, n to the power of 1 by n by 5 to the power of n whole to the power of 1 by n. So limit n tends to infinite, n to the power of 1 by n means 1 by this n getting cancelled, then I will have 1 by 5. So this is a constant. Constant limit is again what? Constant only, which is L. So from the nth root test, if L less than 1, what we can say? Convergence. So mod un is convergence in the ratio test, or which method we applied? Nth root test. In the both the method, friends, in one method if it is a convergent, in every method it should be convergent only. Okay, You don't have other option. If it is a convergence for one test, remaining test also it will be convergent. But sometimes we cannot apply single test, sometimes we cannot apply more than one test, right? Now, so from this what we can say, the alternating series is absolutely convergent. This is the procedure, friends. I think it is clear for everyone. Thank you for watching this video.